Hey kids, welcome to section 4.2, Powers of Binomials. Today we're going to learn something called Pascal's triangle and how you can use it to expand powers of binomials. And then we're also going to use something called the binomial theorem to expand powers of binomials. So two different ways that we're going to learn how to expand powers of binomials. So first things first, this is Pascal's triangle. Pascal's triangle gives you a quick way to find the coefficient that goes in front of each of the expanded terms in a binomial. The It's interesting because in Pascal's triangle, the two previous numbers add to get the one below it. So 1 plus 1 is 2, 1 plus 2 is 3, um, 1 plus 3 is 4, 4 plus 6 is 10, 6 and 1 makes 7, 126 and 84 is 210. All of the different numbers, two above it, add to get the one below it. And these are the coefficients that go in front of each of the terms when we expand a binomial. So for instance, letter A plus B to the seventh power. Well, I could take A plus B and do A plus B times A plus B times A plus B. And I could do 7 of those, and that would take forever. So what we do is we have a little trick that we get to do. The first thing we need to do is look on row 7 on the Pascal triangle. And I'm going to pull up a bigger one. Pascal's triangle row 7 is right here. So the numbers 1, 7, 21, 35, 35, 21, 7, 1. Those are going to be my coefficients. So I'm going to go over here. Let's erase this craziness. Let's go right here and we're going to do 1, 7, 21, 35, 35, 21, 7, 1. Okay, so what we're going to do is we are going to take 1. And then we are going to do the first thing in the parentheses to the power 7. And then we are going to do the second thing in the parentheses to the power 0. Plus. Now we're going to take the next number, 7. We're going to do the first thing, A, to 1 less power, so 6. And we're going to do B to 1 more power, which is 1. Plus. Then we're going to grab the 21. Go down a power for A, so A to the 5th. Go up a power for B, B to the 2nd. Plus, do the next coefficient, 35. Go down a power in A, so A to the 4th. Go up a power of B, B to the 3rd. Next coefficient is 35. Go down a coefficient, A to the 3rd, or go down a power, and then go up a power for B, B to the 4th. Plus, grab the next coefficient, 21. Go down a power for A, so A squared. Go up a power for B, so B to the 5th. Plus, grab the next coefficient, 7. Go down a power for A, so A to the 1st. Go up a power of B, B to the 6th. Plus, grab the last coefficient, 1. A to the 0, B to the 7th. So each time you're putting the number from the row in Pascal's triangle, you're going down in powers for the first thing, and you're going up in powers from the second thing. Then you just clean. So B to the 0 is 1, times the 1 in front is a 1, so this is just A to the 7th, plus. Can't really do anything, so I'm going to write 7, A to the 6th, B. And really, I can't do much anything else. So I'm just going to rewrite it. Seems kind of crazy, but it doesn't require too much cleaning this one. Eventually, they're going to require a little bit more simplifying because you'll have to multiply numbers together or you'll have to add exponents. But this time it's fairly good. Okay, let's take a look at letter B. So this time we're in the 4th row. So let's go grab the numbers for the fourth row. So the fourth row is right here, 1, 4, 6, 4, 1. So those are my numbers I'm going to use, 1, 4, 6, 4, 1. So I put the first number 1. I do the first thing in the parentheses to the power on the outside, 4. And I do my second thing, -3 to the 0 power, plus. Then I take my next coefficient, 4. I do x to 1 less power, x cubed. I do -3 to 1 more power, that's a 1, plus. My next coefficient is 6. Go down a power to get x squared. Go up a power to get -3 squared, plus. Grab the next coefficient, 4. Go down a power, x to the first. Go up a power, -3 to the third, plus. Last coefficient is 1. Go down a power, x to the 0. Go up a power, -3 to the fourth. All right, now we clean. -3 to the 0 is 1 times the 1. We just have x to the fourth. In the next one, we have 4 times -3. 4 times -3 is -12, x to the third. Then I have -3 squared is 9, times 6 is 54, x squared. Then I have -3 to the third, that's -27, times 4 is -108x. And x to the 0 is 1. There's a 1. -3 to the fourth, that's 81. Notice there are no like terms, nothing else that I can simplify. All right, let's take a look and see a little bit more challenging ones. So now we have coefficients in front of both letters. So if we do part A, we need row 5 and Pascal's triangle. That's 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. All right, so I'm going to put the 1. I'm going to do 5a to the 5th power and -4b to the 0, plus 5 times 5a to the 4th, -4b to the 1st, plus 10, and then 5a to the 3rd, -4b squared, plus 10, 5a quantity squared, -4b quantity cubed, plus 5, 5a to the first, -4b to the fourth, and finally 1, 5a to the 0, -4b to the fifth. All right, now we clean. -4b to the 0, 1, those go away. 5a to the fifth, make sure you share the square or share the power. And so this is 3,125a to the fifth. In the second term, we have 5 times 5 to the fourth times -4 to the first. That's -100. Then we have a to the fourth b. The third term, we have 10 times 5 cubed times -4 squared. That's 20,000. And then we have a cubed b squared. The next term, we have 10 times 5 squared times -4 cubed. That's -16,000. A squared b cubed. In the fourth term, we have 5 times 5 to the first times -4 to the fourth. That's positive 6,400. A b to the fourth. And finally, 5a to the 0 is 1 and another 1. So we have -4 to the fifth. That's -1,024. B to the fifth. And there's your answer. So these are not challenging. You just have to be careful. Now you could do this the long ways and multiply it all out, but it'll probably take you the better part of a day. So this is the quickest way. All right, letter B, I need row 6. So that's 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20. Wait, what was it again? 1, 6, 15, 20, 15, 6, 1. All right, so we've got 1, and we've got 3x to the 6th, 2y to the 0, plus 6 times 3x to the 5th times 2y to the 1st, plus 15, 3x to the 4th, 2y squared, plus 20, 3x to the 3rd, 2y to the 3rd, plus 15, 3x squared, 2y to the 4th, plus 6 times 3x to the 0, 2y to the 5th. Oh, not to 0. That's 3x to the 1st. And then finally 1 times 3x to the 0 times 2y to the 6th. Okay, so 2y to the 0 is 1 and 1. So we got 3 to the 6th, which is 729 x to the 6th. Plus, we got 6 times 3 to the 5th times 2 to the 1st. That's 2,916 x to the 5th y. Plus, then we have 15 times 3 to the 4th times 2 squared. That's 4,860 x to the 4th y squared. Plus, now I have 20 times 3 cubed times 2 cubed. That's 4,536 x cubed y cubed. Plus, then I have 15 times 3 squared times 2 to the 4th. That's 2,160 x squared y to the 4th. Plus, then I have 6 times 3 times 2 to the 5th. That's 576 xy to the 5th. Plus, and then 1 and 3x to the 0 is 1. So we have 2 to the 6th, which is 64 y to the 6th. Okay, so that's what we would do if we wanted to expand each binomial. What if I want a particular term and I don't want to go through the whole process of doing all of that? So what if I just want to find the indicated term? All right, well, I want the 5th term in x plus z to the 11th power. Well, first I need to go to the 11th row, which is down here in the bottom. And I want the 5th term. 1, 2, 3, 4, 5 would be 330. So I'm going to put 330. Nope, not 333, 330. Then I'm going to take y and I'm going to take it to the 11 minus 5th power plus 1. The power of the binomial minus the space that I'm in plus 1. And then I'm going to do z to whatever else is left. So this will be 330. Y to the 11 minus 5 is 6 plus 1 is 7. And then z has to be the number that you would add to a 7 to get 11, which is 4. So notice every time that we expanded a binomial, the power is always added in the answer to the original power in the problem. So for instance, 6 on the x is the 6 up here on the binomial. 5 plus 1 is 6. That's the power on the binomial. 4 plus 2 is 6. That's the power on the binomial. 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 is 6. 6. So to get that first one, we're going to look on the Pascal's triangle to find the coefficient in front. The first value is going to be to the power minus the term plus 1. And then the second power is going to be whatever is left to get the total of 11. I know it's kind of weird, but it gets easier. All right, I need the fourth term of the quantity 3a minus 5b to the fifth. So I need to find the fifth row and the fourth term. So fifth row, fourth term. Let's get rid of some of the old ones. All right, fifth row, fourth term would be 10. So I'm going to put a 10. Then I'm going to take the first thing, 3a, and I'm going to do it to the 5 minus 4, the power minus the term, minus 1. No, plus 1. So 5 minus 4 is 1. 1 plus 1 is 2. So I'm going to put it to the second power. And then I'm going to take the second thing, negative 5b, and raise it to whatever power added to 2 gives 5. And that's a 3. And then we simplify. 10 times 3 squared times negative 5 to the third. That's negative 11,250. And a squared and b cubed. And notice 2 plus 3 is 5. All right, letter C, I want the sixth term in the eighth row. So let's go to the eighth row and find the sixth term. 1, 2, 3, 4, 5. 6 is the number 56. So I'm going to do 56. I'm going to take 2k, not 2b, 2k. And I'm going to raise it to the 8 minus the sixth term plus 1. So that's 3 to the third power. And that means negative y is going to be to the fifth power because 3 plus 5 is 8. Okay, now we clean it up. 56 times 2 cubed times negative 1 to the fifth. That's negative 224. And then we have k to the third and y to the fifth. Okay, last one. Third term of j plus 8 to the seventh. So seventh row, third term would be 21. So I'm going to put a 21. I'm going to take j to the power 7 minus the term 3 plus 1. So that's 4 plus 1 is 5. So j to the fifth. And then 8 is going to be to the second since 5 plus 2 is 7. So this gives me 21 times 8 squared. That's 1,344, j to the fifth. Okay, this last slide here kind of just explains and summarizes what we've learned. That in a binomial expansion of a plus b quantity to the n power, there are n plus 1 terms. So if you have a quantity squared, you have 3 terms. If you have a quantity cubed, you have 4 terms. N is the exponent of a in the first term, but it's also the exponent of b in the last. In successive terms, the exponent of a decreases by 1 and the exponent of b increases by 1. The sum of the exponents in each term is n, and the coefficients are symmetric. That's the whole point of Pascal's triangle. All right, kids, that's the end of section 4.2. If you have any questions, please let me know. And as always, keep calm and keep trucking.